Take a look at these student test scores across two subjects. Right now, it's a loose collection of numbers floating on the board. To treat this data as a single unit, we use these brackets. They act as a boundary, defining this specific group of numbers as a matrix. So the brackets are just there to hold the numbers together? Precisely. They indicate that everything inside follows a specific set of mathematical rules. We navigate a matrix using two directions. The horizontal lines are the rows, and the vertical lines are the columns. We define the shape of a matrix by its order. We always list the number of rows first, followed by the columns. A simple way to remember the sequence is the RC in RC cola. Since we have 2 rows and 3 columns, the order is 2 by 3. Even though we use a multiplication sign, we read it as 2 by 3. We don't actually multiply the dimensions together to get a single total. The order is the fundamental blueprint of a matrix. It tells us exactly how much data the container holds and how that data is arranged. What if you only have 1 row or 1 column of data? It gets a specialized name. A 1 by 3 grid is a row matrix. Flipped to a 3 by 1, it's a column matrix. If rows and columns differ, it's a rectangular matrix. When identical, like 2 by 2, it's a square matrix. Then we also have the zero matrix. This is any matrix where every internal element is 0, regardless of the overall shape. These categories describe the exterior of the matrix, its boundary and proportions, without needing to analyze the specific values inside. Now let's look inside a square matrix. The path from top left to bottom right is the main diagonal. If only this path has non-zero numbers, it's a diagonal matrix. If these numbers match, like 3 5s, it's a scalar matrix. If they are specifically 1s, it's an identity matrix. Let's try a quick identification. Look at this 2 by 2 matrix with 5s on the diagonal. Can you determine its order and type? It's a 2 by 2, and since the diagonal has matching 5s, it's a scalar matrix. Correct. These definitions are nested. An identity matrix is a type of scalar matrix, which is a type of diagonal matrix, which must always be a square matrix. Let's test these rules with 2 examples. Matrix A has 1 row, 2 columns, and all zeros, so it's a row and 0 matrix. Matrix B is a 2 by 2 square with 1s on the diagonal, making it an identity matrix. This flowchart summarizes the hierarchy. You start with the broad requirement of being square, then move through diagonal and scalar to reach the most specific type, identity. For your homework, identify the order and the most specific type for this matrix. Post your answer in the comments. Teacher, recognizing these structures ensures you'll know which operations are possible once we move into matrix arithmetic in the next lesson. See you then.